Chapter 2, Section 2. Limits involving infinity. Page 71, Exercise 2. Part A. It says find the limit of f of x as x approaches infinity. The limit of f of x. In exercise 2, f of x is the sine of 2x over x. So we want the limit of this function, f of x, as x approaches infinity. And what we're going to do here is simply look on the calculator. Because a sine function is involved, I'm making sure the calculator is in radian mode. And then I'm going to calculate this expression, sine 2x over x, for large values of x. So f of x refers to this function here that's given. If x is a big number like 9, kind of big, sine of 2 times 9 divided by 9, make sure you're in radians, is negative 0.0834. If x is even larger than 9, like 99, f of x is negative 8 times 10 to the negative 4th power. I got this on the calculator. It's scientific notation, which is actually negative 0.0008. When x is 999, that's even larger. F of x is negative 5 times 10 to the negative 5, which is negative 0.00005. Observe that as x approaches infinity, meaning x gets larger and larger and larger, this thing in here gets closer and closer and closer to 0. This number right here is close to 0. This is even closer to 0, and this is even closer to 0. So that's the answer to part A. Blue box around the answer. Part B says in the directions, find the limit of f of x. That's the sine of 2x divided by x as x approaches negative infinity. And we use a calculator for this. We just x is approaching negative infinity, so we'll plug in negative 9, then negative 99, then negative 999. We call this right here x approaching negative infinity, getting closer and closer to negative infinity. And plugging these numbers in to here, we get amazingly enough, even though I'm plugging in these negative numbers, we get the same y values that we got when we plugged in the positives. That's negative 0.0834, close to 0. Negative 8 times 10 to the negative 4, even closer to 0. Negative 5 times 10 to the negative 5. So getting closer and closer and closer to 0. That's these numbers right here. So that's the answer to part B also. Different question, same answer. Before we answer part C, here's a reminder from when we were studying pre-calculus. If the limit of any function as x approaches either infinity or negative infinity is some number, then y equals that number is a horizontal asymptote. This is actually the definition of horizontal asymptote. Since this function we have here, since the limit of this function as x approaches negative infinity is this number, and the limit of this function as x approaches infinity is this number, they happen to be the same number, then y equals this number is a horizontal asymptote. And that gives us the answer to part C. The question says, identify all horizontal asymptotes. It's y equals 0. So there, we did the whole problem. We definitely needed a calculator to get the values in this table. I'm going to try to show you a graph. You can look at this graph on your calculator. I'm not going to be able to do it, but we'll talk about the graph in class. All right, now I'd like to do number 6 on page 71. Same directions. Part A is find the limit of the function, we're doing exercise 6, 2x minus 1 over the absolute value of x minus 3, and x is approaching infinity. So use a calculator. In this case, the function is what I have this red circle around. X is approaching infinity, so plug in numbers that get larger and larger and larger. So I'm going to do something on my calculator. I'm going to calculate the thing in the red when x is 9. And I got 2.8333. I'm going to calculate this in the red when x is 99. I got 2.0521. Calculate this when x is 999. And I got 2.005. I can see that as x approaches infinity, that's this, f of x is getting closer and closer to 2. So there is the answer to part A. I can just see these numbers, 2.8, close to 2, 2.05, even closer to 2, 2.005, even closer to 2. 2 is called the limit. Part B, the question is find the limit of the function 2x minus 1 over the absolute value of x minus 3 as x approaches negative infinity. That means if x is, plug in a number like -9, then -99, then -999. This illustrates x approaching negative infinity. Just plug these numbers into this. And I got, first, when I plugged in -9, I got -3.6.167. When I plugged in -99, I got -2.073. Plugging in -999, I got -2.007. I'm going to go a little farther this time. Plug in -9,999. And you get -2.001. We see with our own eyes that these numbers here in this column are getting closer and closer and closer to 2. I mean -2. Closer and closer and closer to -2. So get rid of question mark. This is the answer to part B. When the limit of a function as x approaches -infinity is a number, y equals that number is a horizontal asymptote. And when the limit of a function as x approaches infinity is some number, then y equals that number is a horizontal asymptote. So number 6, part C, identify all the horizontal asymptotes. There they are. And you should look at the graph on your graphing calculator. If we have time, we'll look at the graph in class. Number 10, still on page 71. It says limit of x over x minus 2 as x approaches 2. And notice there's a little minus sign after the 2. That means we say x approaches 2 from the left. If we just plug in 2, we'll have 2 over 0. 2 over 0 is impossible. So back to the calculator. This time when I say f of x, I'm talking about this right here. I know that I can't plug in 2 because dividing by 0 is impossible even for a calculator. So we're gonna plug in 1.9 because 2 reasons. 1.9 is close to 2 and 1.9 is on the left side of 2. So important to be close to 2, really close, but on the left side. Plugging 1.9 into this. Plugging into x divided by quantity x minus 2. Let's see, I got -19 in that. And then I'll plug in 1.99 because we say x approaching 2, meaning getting closer and closer. 1.99 is closer to 2 than 1.9. I got -199 when I did that. When I plug in 1.999, I get -1,999. So here's the story. This red, that's what we mean by x approaching 2 from the left. These numbers tell me the answer to exercise 10 is -infinity. Because these numbers are getting closer and closer to something we call -infinity. That's the answer. I want to note, this is not part of the exercise, that if the question said, find the limit of the same function as x approaches 2 from the right, I would like you to see that's actually going to be a different answer. Because if it says x is approaching 2 from the right, we would use 2.1, 2.01, 2.001. We still need to show x getting closer and closer to 2. These numbers are on the right side of 2. So plugging in 2.1 and 2.01 and 2.001, over here, plugging those into this, we get 21, 201, 2001, and therefore, if this purple were the question, the answer would be infinity. Because 21, 201, 2001, these numbers are getting closer and closer to infinity. So just by changing this little thing, nothing else, the answers are different. So I'd like you to try number 12, which says find the limit of x over x plus 3 as x approaches 3 on the right. And I'd also like you to try this. This is not one of the questions in the textbook, but I'd like you to see what happens if you need the limit of x over x plus 3 as x approaches 3 from the left. So try these by plugging numbers into your calculator, and then in class I'll ask you what answers you got. Okay. Next one is number 16. The limit of the secant of x as x approaches pi over 2 from the right. So in the calculator, there's no secant button in the calculator, so we're going to rewrite secant x as 1 divided by the cosine of x. If you just plug in pi over 2, you'll get an error message because the cosine of pi over 2 is 0, 1 divided by 0, error. So be sure your calculator is in radian mode. And what I'm going to ask you to do is plug in numbers. We're going to plug in numbers close to pi over 2, but on the right side of pi over 2. So how do you do that? You're going to plug in, actually use the pi key on the calculator to calculate 1 divided by parentheses cosine parentheses pi over 2 plus a small number. By adding a small number to pi over 2, you'll be at a number that's a little to the right of pi over 2. You should have 2 closing parentheses there. So when you plug in pi over 2 plus a little amount, like 0.1, I got negative 10.02. Then plug in a number even closer to pi over 2. You would say this is close to pi over 2 and on the right side. But even closer to pi over 2 would be pi over 2 plus 0.01. So stick a 0 right there. And when I did that, I got negative 100. And you can keep going. Use pi over 2 plus 0.001. I think you'll realize before long the answer is negative infinity. Right here, I'll write it in red. Because negative 10, negative 100, I predict the next one would be negative 1,000. So function values are getting closer and closer to negative infinity. All right, number 24 is no calculator. It says find the limit of y, which is this, 2 over x plus 1 times 5x squared minus 1 all over x squared. We want the limit of that mess as x approaches infinity. You're expected to do this without a calculator. It can be done with a calculator. All these x's replaced with 9, then 99, then 999, and you'll get the answer that way. But here's the no calculator method. Change 1 to x over x. Same thing. Copy all the rest of this. I changed 1 to x over x so that we could add these fractions. 2 over x plus x over x is numerator plus numerator all over the common denominator. Copy that again. 5x squared minus 1 over x squared. This is multiplication right here. No need for a common denominator when multiplying. We just need FOIL. 2 times 5x squared is 10x squared. 2 times negative 1 is negative 2. X times 5x squared is 5x cubed. And x times negative 1 is negative x. FOIL. All over x times x squared, which is x cubed. Then, in pre-calculus, we did limits like this. To find the limit of a polynomial over a polynomial, what I mean is just terms with x in them, we divide every term by the highest power of x. Notice in each step the limit as x approaches infinity. I just keep bringing that down. So there's no power of x higher than x to the third, so we're going to divide each term by x to the third. 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 Okay, a lot of these fractions can be simplified. So limit as x approaches infinity. 10x to the second over x to the third. That's 10x to the second over x to the third is 10 over x. Because you do this in your head. Minus 2 over x to the third. Copy that. Plus 5x to the third over x to the third. That's just 5. Minus this last fraction on top is 1 over x squared. And down below, x to the third over x to the third, that's 1. Any number over x, or x to any power, becomes 0 when x is approaching infinity. When x is very, 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 very large, like a billion, 10 over x will be 0. Same with 2 over x cubed. Same with 1 over x squared. That means this limit is 0 minus 0 plus 5 minus 0 over 1, which equals 5. And that's the answer to exercise 24. We did not use a calculator. All right, one more, number 48. F of x is a piecewise function. There's two pieces, x minus 2 divided by x minus 1, if x is less than or equal to 0. F of x equals 1 over x squared if x is greater than 0. In part A, we need the limit of this piecewise function, called f of x, as x approaches negative infinity. If x is negative infinity, like negative 100, negative 1,000,000, f of x is which piece here? Well, it's this one, because this is what f of x is up here, if x is less than 0. So numbers like negative 1,000,000 are less than 0. So we rewrite the question, the limit of x minus 2 over x minus 1, as x approaches negative infinity. We're just replacing the f of x with the correct piece, deciding which piece based on this. Yellow. This is equal to the limit of 1 minus 2 over x over 1 minus 1 over x as x approaches negative infinity. I just divided each term by the highest power of x. And if x is negative a million, these are 0. Or someone might say negative 0. 0, negative 0, what's the difference? 1 minus 0 over 1 minus 0 is equal to 1. That's the answer to part A. Part B, the limit of f of x as x approaches infinity. Well, if x is approaching infinity, then the function is this one. Because if x is approaching infinity, like x is a million, a billion, a trillion, all those x's that I just said are greater than 0. So the f of x for part B is which piece? It's the one I put the purple around. So that part up there is irrelevant for part B. If x is approaching infinity, 1 divided by infinity squared. So do this on your calculator. Put a large number in place of x. So figure out like 1 divided by 9 squared. Figure out 1 divided by 99 squared. 1 divided by 999 squared. You'll see the result you're getting will be getting closer and closer and closer to 0. That would be the answer to part B. Part C, the limit of f of x as x approaches 0 from the left. So I say if x is on the left side of 0, f of x is which piece? And we can read, so we know it's this one. If x is on the left side of 0, this is f of x. Rewrite part C like this. The limit of x minus 2 over x minus 1 as x approaches 0 from the left. We're just replacing f of x with the correct piece chosen by looking at this. But then we calculate this limit by just putting 0 in place of x. That's really all you do. X is approaching 0. You say y is from the left there. I'll say again, it's so you know which piece to use. But then you get the limit by just plugging 0 in. So 2 is the answer to part C. And then part D, the limit of f of x as x approaches 0 from the right. This time, since x is approaching 0 from the right, on the right side of 0, this is f of x in the purple. So part D, the question becomes find the limit of 1 over x squared as x approaches 0 from the right. In part C, I said you can just plug in 0 because negative 2 divided by negative 1 is positive 2. Here, if you try doing that here, plugging in 0, you would get something we call undefined. So that's why in part D you have to plug in numbers close to 0 and on the right side. So 1 divided by, you can't say 0 squared, it'll just say error. So 1 divided by 0.1 squared. I plugged in 0.1 because it's close to 0 and it's on the right side. When I did that, I got 100. But I want to make x approach 0, meaning getting closer and closer. So I'm going to divide 1 divided by 0.01 squared. When I did that, I got 10,000. 1 divided by 0.001 squared. That's a million. I can see on my calculator, this right here, 1 over x squared, is getting larger and larger and larger. I got 100, then 10,000, then a million. As I made x get closer and closer to 0. I made x 0.1, then 0.01, then 0.001. So we're calling the answer to part D infinity. So in part C, we just plugged in 0. But in part C, we just plugged in 0. But in part D, we plugged in numbers. We plugged in a lot of numbers that got closer and closer and closer to 0 from the right. So we used numbers on the right side of 0, but really close to 0. So we needed a calculator for part D. No calculator needed for part C. I don't know, do you need a calculator for part D? Maybe. I'd say you really don't need one for part D if you can think about the numbers. And definitely no calculator needed for part A.